In the last video, we split the data into two partitions, two parts, and we ran a simple regression model at each part, okay, using each part. So we ended up with two different models, okay? So what if we manage to combine these models into one and use only one data set? That would be quite practical in many ways because because if you are partitioning your data into many parts, then you would have to estimate several different simple regression models instead of only one multiple regression model. So, and let's see, this is okay. Now we are at the correct slide. Okay, so and one really powerful thing is that this allows us to conduct hypothesis tests for differences across groups. Okay, so what this actually means is that you can test for differences in intercepts and slopes. So actually, if you only have these simple regression models, you don't have a test to say that, well, the intercept between the regression models are different, or the intercepts are different, intercepts or slopes are different. But if you combine this model into a multiple regression model, then you can actually test for differences in intercepts and in slopes. So what we need is to create two additional variables. Okay, so the first one is a dummy variable, and it would be equal to 1 for observations that belong to some group and equal to 0 otherwise. Okay, so for example, our superhost example, our dummy variable would contain the value 1 if the data point is a superhost, and it would contain the value 0 if the data point is not a superhost. Okay, so for example, you would write generate. Instead, you would write generate and superhost. So that's the variable name. Okay, and just equal, set this equal to some value, and then you could write host is superhost is superhost, because this value or this variable we actually have in our data set, and if this is equal to, and remember, two equal signs, okay, this is strictly equal to true, which is a T, and if this is true, then stata puts a 1 into that row. Okay, so stata checks is host is superhost equal to T, then I will put a 1 for true, and if host is superhost is not equal to T, then I will put 0. Okay, so this is just a logical statement which is equal to 1 if it's true and 0 if it's not true. Okay, so the other variable you would need, let's see here, is the interaction term. Okay, so that's an interaction between dummy variable and explanatory variable. So, for example, in our Airbnb example, we have superhost times bedrooms. Okay, and you remember that bedrooms, it's just the count of number of bedrooms for that data point, and superhost, well, we made that a dummy variable. Okay, so this is our dummy variable. Okay, which is equal to 1 if the data point is a superhost, and 0 if the data point is not a superhost. Okay, so for example, if we want to generate this variable, I think I would need more space. We write generate. Let's see, generate, and then we need the name of the variable, so we can just have superhost times bedrooms, long supername, long variable name, and we set this equal to superhost times bedroom. Okay, so how do these variables actually look like in the data? Well, after running these two code snippets, we would have the superhost here, and this superhost variable would just be 1 if this host is superhost variable is true. So here we have a false becomes 0, and true becomes 1, and f is 0, f is 0, f is 0, and f is 0, because here you can see that we only have one superhost in this slice of the data. Okay, and the rest is 0. Okay, what about the interaction term? It's superhost times bedroom. Okay, so what is superhost times bedroom's value? Well, that is the number of bedrooms times the superhost, right? So the number of bedrooms for the first listing here is first data point is 2, but it's not a superhost. Okay, it's not a superhost, so it's 2 times 0, which is 2 times 0 equals 0, right? So let's just clean up, and the next one, it's a 1-bedroom apartment, and it's a superhost, so it's 1 times 1 equals 1, right? So now you see the pattern. Okay, so we just continue, and we note immediately, looking at the superhost, that 0 times the number of bedrooms becomes 0. Okay, so here the superhost times bedroom is positive for only one of the data points in this tiny slice. Okay, we have many more data points, so the algorithm will have no problems counting or calculating the coefficient for the superhost and the superhost times bedroom variables. Okay, so for example, we can use these variables to estimate the population regression. So this is I just want to explain this a bit, because this is a model of the price. Okay, it's a model of the price, and beta naught is the population parameter, it's the intercept for non-superhosts. Okay, and the superhost dummy variable, okay, it's 0 or 1. It's 1 for superhosts, which means that this beta 1 is the change king. Okay, I have to write this correctly. Change in intercept between let's say between non-superhosts and superhosts. Okay, so the beta 1 population parameter is not the intercept for superhosts, it's the difference in intercept between non-superhosts and superhosts. Okay, and the same logic applies to the slope here, slope on bedrooms, which is the slope for non-superhosts, and beta 3 is the change in slope. Okay, the change in slope from non-superhost to superhost. Okay, so what does that mean? It means that we can actually have we can actually perform a hypothesis test on the intercept and the slope, which we could not do with only these simple regression models. Okay, so if we combine these separate simple regression models, then we have the y variable, and we have superhost dummy variable. Okay, we have bedrooms, which is the slope, and we have the interaction term. Okay, and this interaction term will give us the change in slope. The superhost dummy variable will give us the change in intercept. Okay, so the first thing we check is the residuals. So we get or the multiple regression model assumptions, and we just assume they are okay. Just to save some time, you know how to test the assumptions, and we jumped right into the explanatory power of the multiple regression model. So the p-value for the f-test is very close to 0, so we know that there is explanatory power in the model on a very low significance level. So and we see that we can explain about 27.9% of the variation in prices by using these three variables. And what we have here is the dummy variable, because the p-value of the f-test is okay, then we can go on to the t-value, the t-test, and we see that all of these coefficients, they are statistically significantly different from 0 at a very low significance level. And so we can actually do some hypothesis testing with them. And we have the dummy variable, and we have the interaction term. Or interaction variable, you might say. Okay, so what we have here is that remember that for non-superhosts, the value of the superhost variable is 0, and the value of the superhost times bedrooms variable is also 0. Okay, so we have the sample regression equation here, and the estimated price is price hat. This squiggle is just called a hat. So price hat equals the intercept, which is 452, plus the change in intercept if the renter is a superhost. Sorry for the cough. And of course it's negative. It's negative. So it's negative 126. We're rounding, times superhost, plus the slope for bedrooms. It's 286 times the bedrooms, plus the change in slope for if the renter is a superhost. So then we have plus 82 times superhost times bedrooms. Okay, so this is the sample regression equation which you will use to estimate the price of an apartment if you are given the fact that the renter is a superhost or not, and the number of bedrooms. Okay, so you need those two information bits to create the value for superhost, which is 1 for, or let's say 1 if superhost, and this is 1 times bedrooms if superhost. Okay, so these are the bits you need. The if the renter is a superhost, and the number of bedrooms, and then you can calculate the last interaction term. Okay, so how does this look graphically? So we have our sample regression line, and we have here the regression line for superhosts. And how could I find that? It's because superhosts, they have a lower intercept, right? Because they have an intercept term which is 126 below non-superhosts, which is the blue line here, and they have a steeper slope because per bedroom they get 82 extra. Okay, so that's why we know that this blue line is for superhosts. The price or estimated price for superhosts, and this is the estimated price for non-superhost. Okay, so what are the equations for these two lines, regression lines? It's price hat, because it's our guess of the price, or our estimate for the price, and it's for the superhosts. The superhost variable here is 1, so we get 452 minus 126 plus 286 times bedrooms plus 82 times the interaction term. Superhost time bedrooms. Which means that these two combine to the slope, and these two combine to the intercept. Okay, which means that our intercept for superhosts is 326 plus 286 plus 82 is 368 times bedrooms. Okay, so that's the line, regression line for the superhosts, and for the non-superhosts, it's price equals 452 plus or minus 126 times superhost, but for non-superhosts, this term, this 126, is times 0. Okay, so here we get the intercept for non-superhosts, and the slope is 286, and we are not adding the 82 because for non-superhosts, this product between superhost and number of bedrooms, it's 0. Okay, so it's times bedrooms. Okay, so here you have the change is equal to negative 126, right? Which is the 326 minus 452. Okay, so the change in intercept, it's the coefficient on the superhost dummy variable. And the change in slope here, the change in slope between these two regression lines, it's the coefficient for on the superhost time bedroom interaction term. Okay, so we are looking at the predicted price for superhosts. Well, we did that kind of in the last slide, on the last slide, but here you have the dummy variable, and it's equal to 1 because we are looking at superhosts, right? And this is equal to 1. And what we are doing is that we are just setting price. The estimated price is 452 times, or let's say I can do this, minus 126 times 1, okay, plus 286 times bedrooms plus 82 times 1, because superhost is 1, right, times bedrooms, which equals 452 minus 126, which is 326, plus the 286 times bedrooms plus 82 times bedrooms. Okay, so that would be 368 times bedrooms. So that would be the predicted price for superhosts. Okay, so actually this is the same result that you got when you estimated the simple regression model for superhosts only, and that should be at slide 19. So if we go to slide 19, we see that for superhosts, right, we have the coefficient for the intercept, it's 326, which is what we got, and the slope for bedrooms is 368, exactly the same as we got from the multiple regression model. Okay, so if we do the same for the non-superhosts, then this is equal to 0, and this is equal to 0. So we get the estimated price sorry, is 452 minus 126 times 0 plus 286 times bedrooms plus 82 times 0 times bedrooms. Okay, so if we just calculate this, then we have the estimated price equal to 452 it should say, okay, 2 minus 126 times 0, so minus nothing, plus 286 times bedrooms plus 82 times 0 times bedrooms, which is 0, which gives us the estimated price for non-superhosts. Okay, so this is the same result as we got at slide 19 when we estimated the simple regression model with only the data for non-superhosts. Then we got the intercept equal to 452, exactly the same, and the coefficient on bedrooms was 286, exactly the same as we got. So now you see that by combining the data set and making these two new variables, you can actually get the same result, the same result as if you partition the data. Okay, so what we are doing now is that we are looking at the interpretation of the coefficients and on dummy and interaction terms. Okay, so what we have here is the coefficient on superhosts is the difference between the estimated intercepts in the simple regression models. Okay, and here models. So actually, you can if this coefficient is statistically significantly different from 0, then you know that the difference between the estimated intercepts in the two different regression lines or regression models, they are different. So now we actually have a tool to say whether or not there is a statistically significant difference between these two models, okay, between these two groups. And also the coefficient on the interaction term here, it's corresponding to the difference between the two slopes. So now you can actually check the coefficient on the interaction term and see if there is a statistically significant difference between the slopes of the groups. Okay, so you can use let's say use the t-test to check for differences in, let's say, slopes, or we can say intercepts, and slopes. Okay, so now you have the tool to actually make this comparison. Okay, so the Airbnb study, we will continue with that in the next video.